let's try to solve a Leetcode problem 2280, minimum lines to represent a line chart. So we are giving a 2D integer array stock prices. So this line is just the meaning of the stock prices. As you can see, it is fluctuated like this, and the stock prices just indicate the day and price. So for example, for this image, we can say that in day 1 the price is 7, day 2 is 6, day 3 is 5, and day 4 is 4. And what we're gonna return? We need to return the minimum number of lines needed to represent the line chart. Yeah, so we need to return the minimum number of lines. As you can see from the image, there are 1, 2, and 3 lines. But how can we draw this kind of line? Yeah, so according to the time with day and the price of the stock, so we should first sort the stock prices array first. Because our drawing is just like that, we cannot make a drawing like this kind of way. Yeah, I mean, we need to know what kind of drawing we should draw. So we should draw something like this, because the day time is the x coordinates and the price is the y coordinates. So we have to sort the array first. So after sorting, we're gonna check the slope. So if you can say if the slope is the same, we're gonna record it as 1. Yeah, because for a slope, if the slope is the same for those 2 points, it must be the same line. So if the slope didn't change, it must be in the same line for the next dot. So for the next dot, the slope didn't change for the next 2, this one and this one. So it means it's in the same line. But what about the next one? As we can say, the slope becomes 0. So the slope changes, it means it has a new line. So the line becomes 2. Now, for the next dot, it goes here, and the slope also changes from 0 to, I think this is a -1. Yeah, from a -1 changes to 0, and then the slope becomes -1 also changes. So we should plus 1, it will become 3. And now, when we come to this dot, the slope didn't change. And how we compare the slope? We just need to compare the neighboring dots. So for the previous dots, this one with the previous, it's the same slope, and this one with the previous, it's the same slope. So we didn't change the slope. So it means the result would be 3. Now let's try to make another drawing. Maybe maybe we can make another drawing to make it more clear. So this drawing will be like this. So yeah, so if we have some other line, here is a slope, here is flat, and then go down, go top and flat, and here we just make some dash, and here maybe it goes here, and here is another line. Yeah, as you can see that the slope is the same. This one and this one is the same, and also this line and this line is also the same. But we're gonna call it a new line because there is a down, goes down and goes up. So this is the 1, 2, 3, 4, and here is 5, here is 6, and this is gonna be 7. Yeah, even though it has the same slope, but it means 2 different lines. Yeah, so this means we cannot use the K and B as tuple to solve the problem, because even they are the same. If we use a dictionary, it is not okay. Yeah, but we can use the list groups. We can just use the list groups to check if the K and B is the same. We're gonna list it as one group, and then another K and B, another group. This also works. Yeah, but for calculating the K and B, we need to use a division. And if we use a division, it may have the precision problem. So for example, 1 divided by 3 or 1 divided by 999, it's gonna have the precision problem. So we're gonna use a tuple as y2 minus y1. So we're gonna use a tuple to represent the result. Yeah, so for example, if we have two dots, if we have x1, x2, x1, y1, and x2, y2, we are not going to calculate the slope k and b. Yeah, we are only calculate a tuple. So it's going to be the y2 minus y1 with a tuple. So this tuple would be the x2 minus x1. So we are going to calculate such a kind of a tuple. So this tuple gonna represent the k, the slope value. Yeah, but this tuple is not the same. So for example, 4, 2 and 8, 4, it's gonna be different. So we need to divide it by a GCD. So the GCD of 4 and 2 is gonna be 2. 2 divided by 2. So here divided by 2 it's gonna be 2, 1. And 8 and 4 divided by 4 it's gonna be 2, 1. So it's gonna be the same. So we're also going to use this kind of a GCD, greatest common divisor, to solve the problem. Yeah. Now let's go back to the coding. So I'm gonna define a check function. Yeah. So I'm gonna define this check function later, but basically I need this kind of function. First of all, I'm gonna sort the stock prices array. So after sorting, I can find how many lines, how many different, what is the minimum lines. So I'm gonna define n would be length of the stock prices, and the result would be equal to 0. And for I in range 1, I'm gonna start from the second dot. So for example, I'm gonna start from the second dot because I will calculate the slope with the previous dot. So for I in range n, I can calculate the slope. So the slope would be the check function with the stock prices with I minus 1 and stock prices I. Yes, so here currently I got a slope. So this slope would be a tuple. Yeah. So I'm going to compare what is my previous slope. If it is equal, I will not plus 1. If it is not equal, it means I've already found a new line. So I will prepare a previous slope. So pre-slope. So the previous slope would be a tuple. I just give a random value, but it must be unique. It will not appear in my slope function here. So I will give it an infinity and infinity. Definitely this will be unique. It never appeared. Yeah. So I'm going to check if slope not equal to the previous slope. So this means I've already found a new line. So the result would plus 1. Finally, I'm gonna return the result. So for example, my previous slope is infinity and infinity, but currently I can calculate this slope, and the slope would be this one. This one would be yeah, I don't know, maybe minus 1, maybe, yeah, because the division should be minus 1. So maybe the slope is just yeah, maybe the slope is just like yeah, maybe the slope is just like 1 minus 1. It is okay because this minus 1 divided by 1, it is still minus 1. It should be okay. Maybe the slope is like that. So I'm gonna have a tuple like this. Definitely this is not equal to the previous value. Yeah, would not equal to the previous value. So if they are not equal, I'm gonna record the result plus 1, and finally I'm gonna return the result. So the difficult part maybe comes from how to finish this check function. Yeah. So I'm gonna put two dots, x and y. Yeah. So this is gonna be the two dots. So x1, y1 should be equal to x, and x2, y2 should be equal to y, another dot. Now I'm going to check the I'm going to put a tuple. So this tuple would be, yeah, I'm going to use another two values, dy and dx. Yeah, so dy should be equal to y2 minus y1, and dx should be x2 minus x1. But this is not yet finished because we have to divide by the GCD. Yeah, so the GCD should be y2 minus y2 minus y1 and x2 minus x1. And similarly, x2 minus x1 should also divided by this GCD. Yeah, because only by this way we can make a tuple dy dx unique. And finally, we just need to return this tuple dy and dx. So actually this gonna represent the slope. Yeah, because we will not use the division dy divided by dx, because division has the precision problem, so we're gonna use a tuple. So for the tuple, if we were to keep the unique value, we need to divide it by integer division by this GCD. So the GCD would be those two values, y2 minus y1 and x2 minus x1. Yeah, let me just put an example, maybe more clear. So we're gonna use an example to explain this kind of a formula here, maybe. Yeah. So yeah, maybe we have two dots. Y2 x1 x1 y1 should be 1 1, and x2 y2 would be 5 and 5. Let's check the result. Yeah, so y2 minus y1 would be 4 divided by GCD. So the GCD of 4, the GCD of 4 with 0. Yeah, and x2 minus x1, it is also 4 divided the GCD of 4 and 0. Yeah, maybe this is another good example, but I have forgot what is the GCD with 4 and 0. Maybe yeah, the GCD of 4 and 0, maybe it is 4. I think if this is equal to 0, it's gonna be 4. So 4 divided by 4 is gonna be 1, and this GCD 4 and 0 would also be 1. So actually the final result would be 1 1. Yeah, let's just try to check what is the GCD 0 and 4. Yeah, maybe I'm gonna use an example. Yeah, let's just check what is the GCD with 0 and 4. So we're gonna import GCD from math. Import GCD from math. Yeah, let's just check. Yeah, it should be from math. Import GCD maybe. Let's just import the GCD. Yeah, as you can see, the GCD 0 and 4, the result is gonna be 4. So this is why we can use it like that. So we're gonna transform the 4 and 4 to 1 and 1. So we're gonna yeah, we also translate others like 8 and 8 to 1 and 1, and this 1 and 1 would definitely be unique, and this gonna represent the slope. Yeah. Now I think it's enough to run the examples. Yeah. Yeah, it should be stock prices dot sort, or yeah. We can sort it in place. Yeah, now it seems some problems. Let me check. Here is 3 and 7. Yeah, so for the first example, my result is 7. Yeah, because I didn't store the previous value, that is why. Yeah, because if it is like that, definitely it will not equal every time. So my previous slope should equal to my current slope. Yeah. Now let me run it again to check. Yeah, as you can see, it works. Now let me submit it to check if it can pass all the testing cases. As you can see, it passed all the testing cases. Now let's analyze the time complexity. The length of the stock prices is 10 to the power of 5. And here is the sorting. So this is n log n. And this is just a for loop. And inside the for loop, there is a check function. Let's just check the time complexity of this check function. So this check function just used O1 time because we didn't. Yeah, maybe the GCD takes some time, log n time. Yeah, because the GCD takes the log n time. If we were to calculate a GCD, so this is log n time, and this is n log n, and the sorting of the stock prices is also n log n. So the time complexity would be n log n. Thank you for watching. See you next time.